How does Dropout prevent overfitting in convolutional neural networks? Imagine training a model that memorizes every detail of the training data, including noise and irrelevant patterns. This is called overfitting, and it makes the model perform poorly on new data. Dropout is a simple but powerful technique used in convolutional neural networks to stop this from happening. It works by randomly turning off a certain percentage of neurons during each training step. Think of it like randomly unplugging some lights in a room, so the remaining lights have to do more work. This prevents the network from relying too much on any single neuron or feature. When neurons are randomly deactivated, the network can't depend on specific paths or features. Instead, it learns to recognize patterns that are more general and robust. This process makes the model better at handling new and seen data because it has learned to focus on the most important features rather than memorizing details. Dropout is usually applied to the fully connected layers after the convolutional layers, where the risk of overfitting is higher. For example, during training, half of the neurons in a layer might be turned off randomly. The remaining active neurons then have their outputs scaled up to keep the overall signal consistent. This approach is like training many smaller networks at once that share weights, but without the extra computational cost. It encourages the network to develop multiple independent ways of recognizing patterns, which improves its ability to generalize. In convolutional neural networks, Dropout helps by breaking up co-adaptations of feature detectors in both convolutional and fully connected layers. While convolutional layers already reduce overfitting through shared filters and local connections, Dropout adds an extra layer of protection. Dropout has been key in improving the performance of models like AlexNet, which was used for image classification. It helped prevent the model from overfitting large datasets, leading to better accuracy on new images. In the broader field of artificial intelligence and machine learning, Dropout shows how smart design choices during training can make models more reliable. When we use tools like ChatGPT or DALL-E, understanding Dropout helps us see how these models stay accurate across different inputs. It also supports ethical AI development by encouraging models that do not overly depend on limited data, reducing bias. In simple terms, Dropout prevents overfitting by randomly turning off neurons during training. This forces the network to learn more distributed and independent features. As a result, the model becomes better at handling new data, making it more useful in real-world applications. It's like training a team where everyone has to contribute, rather than relying on a few star players. This method helps convolutional neural networks become more flexible, accurate, and ready for real-world tasks.